Good morning, friends. Myself Sridhar H, working as assistant professor in Government Engineering College, Haveri. So this is the third session for your basic electronics, module 1, that is of semiconductor, diodes and application. So in the previous two sessions we have just discussed about diode and biasing of diode. In this session 3 we are just going for this Zener diode. Okay, as you already know that in session 2, that is diode biasing, that always diode will be biased in only forward direction or in the reverse direction. Okay, and only the diode is been active in only one direction, that is in a forward, and there will be no flow of current in the reverse direction. To overcome this, we are just going for this Zener diode. Okay, so this one is the circuit symbol, the same diode symbol with a vertical line with the two dash lines. So the anode represents as well as the cathode. Okay, so this one is the circuit symbol of your Zener diode. So the same thing, the line will be representing your cathode and this part is representing your arrow. Okay, the same thing, the arrowhead points in this direction is the conventional current flow in the forward bias direction. So there will be always in a forward direction, and the Z symbol at the cathode indicates a Zener diode. So this one, if it is a straight line, then it was a normal diode. Since it is represented with the Z type symbol, so we are representing it as a Zener diode. Okay, so this is how it looks like. Okay, anode to cathode, the direction or the path, the dark color, whatever it is representing. So this one is the cathode part, that is the Z part or Z type symbol is known as your cathode path, and the normal direction is known as your anode part. Okay, so what is Zener diode? So Zener diode is a silicon semiconductor device that permits current to flow in either a forward or in reverse direction. A normal diode was what? It was only moving in a forward direction and there was no reverse flow of current. Okay, but to overcome that, this Zener diode was been implemented, and this Zener diode means it will be having in either in both forward as well as in reverse direction. The diode consists of a special heavily doped PN junction designed to conduct in the reverse direction when certain specified voltage is reached. So this is specially designed just for your reverse direction. Zener diode has a well-defined reverse breakdown voltage at which it starts conducting current and continues operating continuously in the reverse bias mode without getting damage. So this one is a means the Zener diode is a for been designed for a reverse breakdown voltage, and that too without damaging the diode. The voltage drop across the diode remains constant over a wide range of voltages, a feature that makes Zener diode suitable for use in voltage regulations. Okay, the Zener bias or the Zener diode is the breakdown voltage of a Zener when it is connected in reverse biased. Okay, so this one is just true for the, so it has been designed for what? For the reverse breakdown voltage. Next, a Zener diode. So this one is equivalent circuit in forward bias. As we know that Zener diode is working in both forward biased as well as in reverse biased. Okay, so this one is the ideal in how it will look like, but in practical we will be connecting with the resistor, and this one is acting as a closed switch. Since it is been connected, so it is acting as a closed switch. So this one is the equivalent circuit in a reverse bias. So this reverse bias means, so for the voltage below breakdown voltage, VZ acts as a open switch. So until the breakdown voltage, it will be acting as a connected one. So that is a closed switch. Next, at as soon as it reaches the breakdown voltage VZ, it acts as a open switch. Next, so this one is the equivalent current in a reverse bias. So negative to power VZ, that is a breakdown voltage. For the voltage above breakdown voltage, so it acts constant voltage. So as in ideal as well as practical. So practical means we will just connecting a source resistors, that is the breakdown voltage thing, and it acts as a constant voltage source. So considering this, so it is acting as an open switch, and now it is acting as a constant voltage source. Okay, so Zener breakdown So how does this, when does it the Zener breakdown occurs? So Zener breakdown mainly occurs because of high electric field. So whenever there will be high electric field or high electric current, then it will be forming a Zener breakdown. When a high electric field is applied across the PN junction diode, then the electrons start flowing across the PN junction, consequently expands the little current in the reverse direction. Okay, next, or it can also be defined as, so when the diode is reverse biased, the kinetic energy of the electrons increases and they move at high velocity. So whenever in a PN junction, as we studied in the first session, that is for a PN junction. So when a high electric is being connected or the biasing, so the depletion region is formed at that part. So if you just give a high current at that point, it expands and it will be occurring in a reverse bias. Okay, the high electrons collide with other atoms and give rise to free electrons. These free electrons in turn give rise to a high value of reverse saturation current, and this one is known as a Zener breakdown. Okay, so there is another breakdown, that one is known as your avalanche breakdown. So this avalanche breakdown occurs when high reverse voltage is applied across the diode. Okay, so when the for reverse breakdown, that is the Zener breakdown occurs when it is high electric field. So it also occurs to avalanche occurs when a high reverse voltage is applied across the diode. As we increase the applied reverse voltage, the electric field across the junction increases. As this is already know the concept, as we increase the applied reverse voltage, the electric field across the junction increases. This electric field exerts a force on the electrons at that junction and frees them from covalent bonds. Okay, these free electrons start moving in with high velocity across the junction and collide with the other atoms, thus creating more free electrons. So whenever you just been connecting with the uh, voltage, as we increase, so at that time the electrons or the covalent bonds will be just free. So these free electrons with high velocity across the junction and collide with other atom, thus creating a more free electrons. So this results in rapid increase in net current known as avalanche breakdown. So one is the Zener breakdown, and another one is the avalanche breakdown. So this one is the, now we'll just go for your difference between the Zener and the avalanche breakdown. So what are the main differences? So Zener breakdown, this process in which the electron move across the barrier from the valence bond of a p-type material to the conduction band of n-type material is known as a Zener diode. So when it is moving from the p-type to n-type, at that time it is known as a Zener breakdown. And this avalanche breakdown occurs when is applied high voltage and increasing the free electrons or electric current in the semiconductors and insulating materials is known as the avalanche breakdown. Just by applying the voltage and increasing the free electrons, at that time the avalanche breakdown occurs. So next, second point is Zener diodes having a Zener breakdown voltage of 5 to 8 volts. Okay, so in the avalanche breakdown, what is happening? It is greater than the 8 volts. So this next, the increase in temperature decrease breakdown voltage, the increase in temperature increases breakdown. See here, the increase in temperature decreases the breakdown voltage, and in avalanche what will happen? The increase in temperature increases the breakdown voltage. Next, the valence electrons are pulled into the conduction due to the high electric field in the narrow depletion region, and the electrons are being pushed in avalanche breakdown. The valence electrons are pushed to conduction due to the energy imparted by accelerated electrons, which gain their velocity due to their collision with other atoms. Okay, so this one is occurring through the, when there is a happening a collision with the other atoms whenever to measure the free electrons. The VI characteristic of Zener breakdown has a sharp curve, and the VI characteristics of avalanche breakdown is not as sharp as Zener breakdown. Okay, next, it is Zener breakdown having a sharp curve, and in avalanche breakdown it will not be having as much as a sharp curve as Zener diode. And the last one, it occurs in diodes that are highly doped, and in it occurs due to in a lightly doped. Okay, Next, so these are the VI characteristics of a xenodiode. So when it is happening in a, what is happening in a forward bias and reverse bias. So first thing is, so forward bias means you will be connecting positive terminal is be of a voltage source is connected to a anode part, and the negative terminal is connected to a cathode part. So this is the forward bias reason. So this one is the sharp curve whatever it has been getting, and this one is the knee voltage, the forward voltage versus the forward current, and this one is the breakdown voltage, that is the minus Vz. So for the forward bias the breakdown voltage will be the 0, and this one is the reverse biased current. So see here, so this one is the VI characteristics of a xenodiode. Okay, see here, the characteristics of xenodiode in forward bias is same as normal diode, so there is no much difference. Okay, but the same thing when it is reverse bias, see here, so it is having a cut-in voltage, the knee point, as well as this one is known as the xeno breakdown part, and this part is known as a avalanche, this one. Okay, see in a reverse bias, what the same thing, what you will be connecting, the negative terminal of a voltage source is connected to anode, and the positive terminal of a voltage source is connected to a cathode. So this is the reverse biased characteristics. So this one is the current max, and this one is the Iz min. So this one is the reverse current of a xenodiode. So minimum current, this one is the maximum current, and this one is known as the knee point, that is a negative source, and this part is known as a xeno breakdown voltage. Okay, so this one is for cut-in voltage for germanium, and 0.7 for the what, silicon. So this one is just the forward bias characters. Next, so this one is being constrained in a fold, both forward biased as well as a reverse biased. See here, so this one is forward bias region, so this one is the reverse bias. So we will be getting a constant 0 voltage here. So this part is known as a xeno breakdown, and so these are the cut-in voltage for a forward bias, that is 0.3 for germanium and 0.7 for silicon. So this one is the knee point. So this is the curve whatever you people are been getting, so that one is known as the thing. So next, so xenodiode specifications. What are the specifications of a xenodiode? So some commonly used specifications for xenodiodes are xeno breakdown voltage, that is the xeno or the reverse breakdown voltage ranges from 2.4 volts to 200 volts. So depending upon what kind of xeno breakdowns xenodiodes you have been using, so the voltage ranges from 2.4 to 200 volts. Sometimes it can go up to 1 kilovolts depending upon the design, and while the maximum for the surface mounted device is 47 volts in standard. So normally the xenodiode whatever will be having for 47 volts, and the current constant Iz max, and it is the maximum current at the rated xenodiode voltage, that is 200 microamps to 200 amps. So current Iz minimum, as we have seen that two parts, that Iz minimum as well as Iz max. So these are the two, that is for Iz max it will be having 200 microamps to 200 amps, and Iz minimum is the minimum value of the current required for the diode to break down. Okay, so the minimum voltage whatever it is be represented, and that one is known as the Iz minimum, and that is represented by a I naught. So next, power rating, it denotes the maximum power the xenodiode can dissipate, and it is given by the product of the voltage of the diode and the current flowing through it. And the next one is the temperature stability. Diode around 5 volts have the best stability. So normally in electronics almost all the devices have been working for just the 5 volts, and now it has been reduced to 3.2 volts because just for the reduction of the power. Okay, so in previously almost all the electronic devices were been designed for the 5 volts. Next, the voltage tolerance, it is typically plus or minus 5%, and xeno resistance, it is the resistance of the xeno diode. Okay, next, so where these xenodiodes are being applied. So xenodiodes have a large number of applications, and we will just going for a few of them. So xenodiode is used as a voltage regulator. So where in the next we will be getting over of the regulators. So at that time these xenodiodes will be just used. And the next, the xenodiode is used as a peak clipper in a wave shaping circuits. So Zener diodes are also used at the clipping and clamping circuits. So Zener diode used as a fixed reference voltage in transistor biasing circuits. So Zener diodes are being used in a transistor biasing circuits, and it is also meter protection against damage for accidental applications of excessive current or excessive voltage. So these are the applications of the Zener diode. So Zener diode means in almost it has been applied in every material of the electronics, that is in the voltage regulators, so clippers and clampers, as well as in transistor biasing, as well as for the accidental applications of excessive voltage. So whatever the damage is being created. Okay, so main thing is, so we are just going for this characteristics. Why Zener diode was been means normal diode was been always active for only for the forward bias, and there in a reverse bias there was just the no flow of current. To overcome that, we are just going for this Zener diode, and this part, the reverse breakdown voltage is been getting across this Zener breakdown region, and so we will be getting 2 volts, the IZ minimum as well as IZ max, and here we are being coming across 2, we are, that is Zener breakdown as well as the avalanche breakdown. Okay, thank you, and this completes your session 3 of a Zener diode.